I mean, I said the title just by checking whether or not it was time to start. Is it time already? And I'm sorry about the somewhat cliché-matic title beneath that about microservices, because we're going to talk about microservices and how we talk about microservices, because I think it's long overdue that we had a refreshing look at that. I like microservices. I want to use them as much as possible. But let's see about how you should do that. My name is Bert Laverman. I'm a software architect and developer. I work for a company called Axonic. We're not going to go into all the products of Axonic. If you're interested, come and visit us at the booth, because today we want to talk about this, microservices, and especially start with the name, because the name, of course, signifies a very important aspect, size. However, what size then should be right? I don't know about you, but I heard a lot of different stories about what is the right size for a microservice. I think the most interesting and probably useful one, if you want to estimate it in a certain way, that I ever heard, is the one that says it should be small enough that you can build it in a single sprint. That has a reason, of course, because that also means that you could replace it in a single sprint. However, that does imply that if your application grows to a certain size, you're going to get quite a lot of microservices, and that is not something that is always nice to have to deal with. So when you go out and talk about that, what happens? Along comes Gartner and says, well, it doesn't need to be micro, you could also do mini. That kind of makes the problem a little bit less big. And then, of course, we might already have an application. So we have a monolith. We can strangle that and slowly replace that with microservices. Again, that reduces this phantom of having a huge collection of very small services around. And then if we do have a greenfield situation, well, I don't mean you really have to start with microservices. You could just start in the traditional way, build a monolith and make sure that you build it right, so later on when the need arises you actually can move to microservices. And that kind of brings us to the other thing which you see up here. If we're talking about microservices, we usually do that because we contrast them with a monolith. Now, what really is a monolith? I found this picture of a sculpture in Oslo. And I don't know if we have anyone from Oslo or neighborhood, but this is called the Vigeland monolith. And I think this kind of represents very well what we consider to be bad about a monolith. A monolith is made of lots of internal components, and those components are so interconnected, interwoven, it's very difficult to isolate those components, and that makes them very difficult to deal with. Funnily enough, this sculpture actually has a very nice surrounding, because if you take a few steps backward, you see it's not just the monolith, but there is this whole collection of small sculptures surrounding it, some of them with similar characteristics, some of them look a bit cleaner, but it's clear they're all connected and they are all together. And that is what you also see with our software monoliths. It's rarely just a single application, it's often also a large collection of smaller applications around them. And then if we do want to go and split microservices off, then we run into that other big problem of microservices that doesn't have to do with size, it has to do with how to deal with them, how to make them run. Because if you want microservices, you better make sure that you have build automation, test automation, deployment automation, health monitoring, and then if we're at it, and we can see that a microservice is not healthy, then we just as well might go on and do infrastructure automation, replacing them, restarting them, rebuilding the entire environment. Because if we don't, then we get problems if our infrastructure looks like this. This is, of course, a very famous picture of the microservices architecture of Netflix. And in this case, I got this picture from a company that sells monitoring software. And they use this saying, you want to know what's in there, because if you don't know what's in there, then the light at the end of the tunnel is the train that is running at you. So the problem is, if you go and do microservices, and if you want to convince your boss that you want to do microservices, they're going to ask you, yeah, but why? What it's going to do for me? Even worse, it might not be you asking for the microservices, it might be the boss, because somebody told them, do microservices, and that's good. You're going to be more agile, more scalable, it's modern, it's good, you're running in front of everyone else. They want tools, they want something that you can buy, implement, and voila, all your problems are solved. And that's the thing, it isn't really a tool, it's a concept. And we had that problem before. I don't know how old everyone is here, but if you're my generation, then you know about service-oriented architectures. And service-oriented architectures, we had the same problem. Because how they were intended, actually, they were intended simply to promote reuse of software. If I already have a certain function, don't make somebody else within the company re-implement that same function, provide it as a function, as a service, make sure that it's being reused. And also because the first one generally is the one that gets the functionality, you settle ownership. That's very nice. That gives a lot of clear ownership domains within your app, within your business. Then it helps you improve software quality. If only one department is owner of a certain service, that department usually is also the one that knows best how to implement it. And we can't get half implemented versions in other departments. We only have the right one that does exactly what it needs to do. And if we have something, we can reuse it, so it improves developer productivity. Unfortunately, that's not what happened. What happened instead is it became a tool. So it became something to promote middleware, enterprise service buses, gateways, protocol translators, you name it, API managers, that kind of stuff. And not just yet that, but it was a development platform. And I've worked in a large insurance company, and what happened there is that the enterprise service bus was of course put within the domain of IT because everybody needed to connect it. You couldn't give it to a single business domain. It was owned by IT, and suddenly business domains are deploying new services with new functionality on the enterprise service bus. So then who owns it? Is that IT? But IT is not business. I mean, all kinds of messes that we got ourselves into. And then, of course, the next thing is, because it's in there, it's being used, everybody starts being afraid to change. Because if I change it, then suddenly half the company will have non-working applications because they were all connected to that one service in there. So instead of helping us, it's becoming a liability. And of course, it's used to manage costs rather than productivity. And that's something we didn't expect at all. So, microservices, are they going to do any better? What are microservices for us? And I'm just going to follow Martin Fowler and say, well, what they are meant to do is do one thing and do that well. organized around business capabilities, designed for fault tolerance, because of course we have now our application split into multiple parts, so if something goes wrong, it's very explicit. Replaceable components if they're small enough. They should be as much as possible stateless or with a local state only. Infrastructure automation and DevOps, apply that as much as possible. And most of all, center on products rather than projects. Unfortunately, again, this is not what happened. Reality bites yet again. People just focus too much on the name. We don't say do one thing and do that well. No, it has to be small programs because it's microservices. Then organized around the business capabilities, well, no, because they are services, they've got an API, and oh, that's a REST API, so we need to have a consistent API, and then suddenly what you put in that service is determined not by who owns it, but rather does it fit with the API. If it doesn't fit with the API, it becomes a new service. If you thought it was a new business function and a new service, they say, no, that's part of that API, so it must be there. That was not the kind of fight that we wanted to fight. Fault tolerance, well, yeah, so we get the Netflix components, we get Istio, we get all those other things. Basically, we know we need to take care of it, but it's difficult to do it right, really. So we just put somebody else's problem field. I don't know if there's anybody here who has read The Hitchhiker's Guide to the Galaxy. You put somebody else's problem field over it and you can just forget it. Replaceable components, well, they just turn out to be too big, so they are not replaceable. Stateless with local state, you didn't think we could get rid of all those big databases, did you? Then infrastructure automation and DevOps, definitely that's good, but we're going to do it the enterprise way. So the ops team is now called the DevOps team, but mostly just on the basis of that they're now also responsible for the build and test pipelines, not that they're really part of the development team. And then of course we've got new titles, fancy new titles like site reliability engineer and such. I mean, things get changed. Products, not projects. I've tried several times to explain to a manager that I know well, he just happens to be the CEO of Axonic, about Agile and how that works and projects, why they don't work. And he says, well, I look back at my long history and projects work. I don't care that the scope changes, that's what we have change management for. But at least now I can do budgets, and that's important for me. So, yeah, microservices seem to go the same route and running into the same kind of problems. And we forget that microservices are about being agile. And then, of course, also I want to look at the people who do write the applications and say, don't forget, being agile is not an IT thing. It's business agility, it's about the company and the products of the company, and we want to be able to respond to changes in the market, bring new products faster towards the customers. That's what it is. I know IT people aren't always able to influence that, but still that is the focus it should have. So the whole agile software development movement, although it came out of IT, there might be situations where you actually see that business picks it up and then claims it was their idea, but it's all about changing the way you look at work and how you work and being able to deal with change in a way that goes beyond just saying we need a budget for the coming 1 or 2 years. But of course, Agile, as Uncle Dave has told us, has changed, and it has become more of a project methodology. Now, all those Agile methodologies, there's not necessarily something wrong with them. they can help us bring structure in the way we work, but at a certain moment, all that stuff that comes around being agile makes us becoming more of doing agile, and that brings us away from what the core of it is. And the core of agile software development is very simple. Uncle Dave said that it's just a few steps. Step 1, look where you want to go. Step 2, take a small step in that direction. Then 3, evaluate what it did for you. Rinse, repeat. That's all it is. And there are a lot of ways that you can actually mess this up, even though you think it's a very simple thing to do, because there are many implications of doing this that you might not have thought about. One of them is that actually the process is just as much something that you should evaluate and adjust as what you build. So thank you, Dave. He helped us in 2015 and told us we should refocus. Then, of course, we've got Lean. Now, actually, I've seen Lean Six Sigma already mentioned earlier today, and that's too bad. For me, I mean, I understand, but Lean Six Sigma is about making a process measurable, really measurable in the sense of producing digits for it, and then finding quality metrics and making sure that I'm going to improve that process in so many digits behind the comma. And that's really the basis for the 6 in Six Sigma. You're going 6 digits after the comma. In itself, Lean is not wrong, but please do keep your eye on what is important. And for Lean, what is important is that you look at eliminating waste in your process. And waste for software development is things you did while you didn't need to do it afterwards. Also, amplifying learning, making sure that you learn of the process, decide as late as possible. This is something that is very difficult, especially when you have people saying, well, yeah, agile, I know, but I mean, look at building houses. You cannot build a house agile. I mean, I know I want a whole house. I don't want to stop halfway and say I'm going to do something else. So it's difficult to do that right. At the same time, you want to deliver as fast as possible. That doesn't mean you want to deliver everything as fast as possible. You want to deliver something as fast. You want to focus as being able to deliver something useful. Then the team should really be in control of both what is being done, what is being built, the product, but also the process that is used for building it. Build integrity in, look at quality, make sure that the team also feels responsible for that quality, and optimize the whole. A very good book, Mary and Tom Poppendick, and if you haven't read it, read it. It's actually bases the whole lean software development on the Toyota lean production method. It tells a lot about it. Of course, it's based on agile. And then we have got DevOps. DevOps, again, something that has grown quite big. I mean, we have complete pictures with all the different things that you need to do to deliver software and keep improving your process. The basis, again, for DevOps is relatively simply the most important thing about DevOps is removing barriers to communication, making sure that you have an end-to-end responsibility with the team. And that means it's not the application is finished, now operations needs to bring it to production. It's really the end-to-end responsibility. Product and not project. And you see things repeated here that I've said also with the previous slides. Continuous improvement, elimination of waste is just as much something that is stressed here again. automate all the things. That is, of course, something that is typically very much associated with DevOps. Employing fail fast, heard that one already before. User focus, short feedback loops, there it is again. Also here, very good book, Accelerate. If you haven't read it, I can certainly recommend it. This is a book that actually is based on research where they proved with numbers that it works and that it improves the quality and eventually will improve the process and thereby the speed, so the productivity of the team. Very good book. Then, yeah, nowadays we cannot say anything without somehow making a link to AI. However, I'm not going to talk about ChatGPT. I'm talking about the cause for ChatGPT, which is AlphaGo. It started with AlphaGo and a company called DeepMind, which is now part of Google. The game of Go is a very nice game. I like it a lot. Played on a 19 by 19 board. It's a very large board. It used to be the go-to game for any research in AI because it was considered to be too difficult. I mean, they couldn't pull off the same trick that they did with poor Garry Kasparov, because on an 8 by 8 board you just take something big from IBM and then you can brute force pattern matching on it. Poor guy. 19 by 19 is simply too deep a problem. That doesn't work, and for long years any kind of computer Go program was beatable by any competent club player, and if you were a professional Go player, well, you can give it 9 or 10 or more stones as handicap and still beat it easily. But DeepMind changed that. I don't know how many people here in the room know the name of the game of Go, but let's just take a small sidestep into how that works. You can start by using a 13 by 13 board, which reduces the problems and makes it a bit easier to understand. You can even go to a 9 by 9 board, so let's do that for the example. Go is a territory game. So you start with an empty board, you put stones on the board, and with those stones you build walls around empty pieces. And then when the game is finished, you count how large an area you've managed to claim of the board. So you're not going to put stones there at the bottom and then one by one build a wall upwards. You're going to sketch it out as quick as possible. Black starts, so let's give black here a stone in the right bottom corner. Black begins there. Then white takes another corner and black says, let's just go for the right side. Okay, white then says, okay, I'll take the left, no problem. So just looking at that, you see here there's going to be a territorial dispute, and because black is the first mover, black is in an advantage. Can place the next stone and black puts it there, and you see definitely white has a problem. So what do you do as white? Well, you want to reduce this claim. For example, you could place a stone here, but in this case you see that there is not much territory to be had in the center, so this is not going to solve your problem. Instead, what you do is you invade deeply. That gives you a fight. We're not going to go into details of the fight. Let's just make it a nice fight and just say, that corner, haha, I'm going to take that away from you. Game progresses, not many rules in the game. I'm not going to go into the details of what happens here, but you see and get a feeling of what is happening here. White has taken that upper right corner away from black, and now this stone here on the right of black has been completely encircled. That is another important rule within Go. If a stone has no more liberties, it's taken from the board and it's an extra point for the opponent. So away the stone goes, and we'll just let it run a little bit faster. It's a reasonable game, although probably you could try to do some other moves here, but it's not entirely unreasonable. Finished now. There's no more empty space between white and black that we can claim. So let's see what happened. Black here has this area in the center. We can count all the empty spaces, and black has 17 points. White has the lower left corner and the upper right corner. And white has 19 points territory plus another one for the one stone that it captured in the beginning. So that's basically all there is to the game of Go. If you haven't played it, try it, it's nice. And there are parallels with software architecture. When you play a game of Go, you start with that empty board. So you play kind of roughly, you put down some patterns, and you find out that certain patterns are more resilient to change. So you have something that you could call a design pattern. There's also a certain group of patterns that are known to be very problematic, in the sense that once the opponent starts to attack that, you're actually pretty quickly in problems. So there are also bad shapes that give you a very bad result very quickly. And those parallels help you if you're a software professional, or at least they will invite into your mind the ideas that you're doing quite the same thing. Now, of course, we get computer Go, and now the story gets interesting. DeepMind approached deep learning, used deep learning to approach the game, and they kind of mimicked what a real professional does, and they thought, let's see how well it does. And they went to the strongest professional player in Europe, a 2-dan professional, and beat him in an even game. So that got everybody's attention. Something was happening here. The next year they went to the top player in Korea and beat him 4-1. And now really everybody was starting to take a look at what is happening here. This has never happened before. This was considered too big of a problem. They cannot have done it brute force, so really they have some kind of AI technique that works. And in their third version, I think it was AlphaGo 0, they actually didn't train it on the hundreds of years of games that were available from the history of Go. It's a very old game. And they said, they just gave it the rules and then told it to just start playing against itself. So the first few thousand games were a complete mess, but at least something happened, and it started to learn. And it started to learn a certain approach to winning. It then played the strongest player in the world of that time, a Chinese 9-dan professional, and beat him. A few years later, AlphaGo stopped appearing on international Go servers, but suddenly everybody knew DeepMind, and that definitely was what they intended when they started doing this. Now the funny thing is about the way AlphaGo plays, we as a human sometimes lose track of what is important. AlphaGo continually evaluates the state from where it wants to go. If it sees that something is hopeless, it will just stop doing that. Call it fail fast. But more interestingly, whereas human players, especially for the last 100 years or so, had learned that you can do a lot with influence and make large-scale structures and fill them out. Instead, AlphaGo said, that's nice, but I think I can get to my goal faster if I make small steps and take small pieces of territory. So AlphaGo actually learned about lean and agile all in itself. You'll forgive me that, but anyway, let's go back to microservices. So of course, the main story for me is lean, agile, and DevOps is what brings us to microservices and not the other way around. Business agility requires for software development to employ lean software development and agile approaches and everything that comes with DevOps. We make small steps and we automate as much as possible. That means we also get small deployments. And we want those deployments to not cause an entire deployment across the whole company. We don't want 5 deployment windows per year where half the applications are replaced. So we want as much loose coupling as we can between all those applications. And that gives us faster ideation to implementation. I love that phrase. It's real marketing genius, whoever thought of that. So microservices really should be seen as a consequence of agility and not a tool to achieve agility. There are some related concepts, and several of them have already been mentioned or are commonly referred to. Of course, the first is domain-driven design. Another book that I like a lot, if you haven't read it, go out and read it. Domain-driven design is all about tackling the complexity within your applications, and it helps you in structuring your design activity in such a way that you learn how to put boundaries around domains, contexts, smaller subdomains within the larger domain, and make sure that within that domain you can develop your application without having it be contaminated by things surrounding it. Another one, CQRS, something that is very important for the company I work for. This is the space we are very much interested in. CQRS, I talked to my former employer, or at least the programmers at my former employer, an insurance company, and told them, the company I work for now, we do a lot with CQRS. How about you? And they said, well, yeah, we looked at it, but it's quite different than what we're doing, and it makes things more complex. Actually, CQRS is all about separation of concerns. I mean, it's in the name. It acknowledges that what happens with your applications, that you want to have an optimized data model for updating as well as for reading. I mean, I don't know how many of you have done the really old-fashioned way of doing data modeling, going to the second normal form. And what did you do afterwards? You started denormalizing. Why? Because you wanted to also be able to optimally read. And then if you have a really big data model, you get somebody who is really good at it, and he starts making views and materialized views and adds all kinds of indexes. And the end result is that you have as much as possible performance on both sides, but unfortunately neither side really wins. CQRS says stop doing that, just make sure that you have those two separate. Nowadays we can have a lot more applications with a lot more memory. Having a separate read database, read model is nothing strange. Actually, that insurance company had a lot of projects like that where they actually just did that. So they just didn't call it CQRS. Event-driven architectures, also thanks to a lot of messaging software that we have nowadays, we see that a lot. It's very important, helps us decouple applications instead of getting data from the owner of the data. The owner of the data posts events about changes to that data. If I'm interested, I plug into the event bus, I get those events. Now, if I also have an event store where I store the history of the events, that means it doesn't really matter when I plug in, I can start with a replay. And I have an audit log. so I don't have to keep a separate auditing database. And then with event sourcing, I can further refine it, because with event sourcing, I say on the command side, where I'm creating, updating, or deleting, I'm no longer storing the current state of my entities or aggregates in a database. I'm there also replaying the events. Works quite nicely, and if you haven't looked at it, again, visit at the booth and we'll be happy to explain everything. Reactive programming, of course, helps us to further decouple the way we write our applications. Doesn't matter whether you use ReactX or Reactor or just go for Spring and see what it pulls in. Asynchronous communication, and of course, as a consequence, eventual consistency. This one, for a very strange reason, gets a lot of people confused. Many people think, okay, eventual consistency, I mean, when I have a transaction, I want a consistent result. I don't want it to be eventually consistent. It needs to be consistent always. Well, if you've ever built the please wait or thank you for your order may not be shown immediately, or I can just show you that the order has been entered, but you don't see it yet reflected with full status, then you have dealt with eventual consistency. So just like CQRS, there's nothing new, it's just the official term for what you were doing already. So why are we still not all doing this? Well, the most important one, of course, is the phrase, we're doing fine as we are. And I think the most interesting one, it's often difficult to fight, but let's just start with things like DevOps. How often do you go to production? Even nowadays, there's still a lot of companies with less than 5 production deployments per year. So, well, that's your problem right there. Master data management systems. Those things are expensive. They can also be seen as, for example, a huge Oracle database. Oracle loves that. They love to sell you that. It'll be very expensive, highly available, very performant, as long as you put enough iron in it or a big enough VM. But I mean, you're just trying to solve the problems of not doing CQRS. Forward caches, read-only copies. I've been in those kind of discussions. Set up a forward cache. Okay, what are we going to do? Are we going to send the updates onwards and then put the updates also in the cache? And then people grew worried. What if we miss event for updates? You know what? Let's just do a daily batch job and rebuild it. Yeah. So, I mean, you can say we're doing fine as we are, but basically a lot of the projects in especially larger organizations are around having to deal with not doing fine as we are. Then the database. Database is a detail. Again, something that Uncle Dave at a certain moment started saying. It's of course very much something that comes up with Agile and with DevOps. If I start with a small program, initially I might have only a little bit of data, so why not just store it in a flat file? If I really need a database, I'll see later. I might want something like MariaDB or MySQL or Postgres if I really want an SQL database, but I might not need it. Well, why do you want to do that? Enterprise standards reduce costs and waste. We already have invested so much in that database technology. Use that, and we don't want a chaotic free-for-all in all our tooling. But the problem is, of course, that the underlying assumption is that this solution works well in all situations. And if you've ever been in a project that thought, well, we can have a first version out quickly, only to find out that you then lose another month before the database is finally available of your small application, then you know that that's not always the case. And this one is, of course, something that we see more recently. People do want to start microservices and then say, okay, but let's not just start with it. We just start with a monolith. Now, there is nothing inherently wrong with that. Just be careful, because legacy that got us into trouble before. It's easy to keep adding small things. But don't forget, now and then you take that step backwards and you say, okay, now what do I have? Do I really want to tack another little bit to this? Or do I need to start refactoring? And there we even get help from our friends at Gartner. Even they said at a certain moment that you should count on about 20% of refactoring. That means that you should either make sure that you mix in refactoring stories within the normal stories, or you're going to tell your product manager, yeah, the next sprint is going to be a refactoring sprint. What? No new functionality? Yeah, I'm sorry, but you kept us going. We need to clean up. If we don't, we're going to get a problem. So, finishing up. Beware of seeing microservices as a means of an end. They're not a tool you buy, they're not something that you do and then it'll solve all your problems. If you try that, well, unless you already know how to deal with them, it's more likely to get you into trouble than really help you. Make deployments to production something that you really consider easy. I've been in a project and it was a small program, but at a certain moment it really was about, okay guys, we're going to do a production deployment tomorrow. Who wants to help me? It was something that had grown already so complex that they wanted to have 2 people really doing that, preparing that, because it was not something that you could do with a single push of a button. And that's what you want to have if you want to be able to move fast. Consider that monolith a smell. It's not something that is bad per se, but the fact that you have it means that you are easily getting into other problems. And the database, so try to keep it as local as possible, because a database can tie an application or a group of applications down as much as an API. And CQRS, don't be afraid of the term. It just formalizes common sense. And okay, that was actually the last one. So that is last bit. Ooh, I managed to do it within 45 minutes. So we even have time for a question if there is one. And if not, I'm just going to say, please come and join me at the booth if you want. And if you happen to be in Amsterdam in September, join us there at the Unconference, and we'll talk a lot about CQRS, event sourcing, microservices, and all those other interesting subjects. Thank you.